Hello guys, today we're finally doing more geometry and I'm also finally back from the trip and that's why I didn't post a video yesterday because I got home at 1 a.m. So we're starting with this problem. AHSME problem 22 of 1963. Read the problem yourself and pause the video, see if you can solve it by yourself. And there's also a graph down here that doesn't have any information, so you can just use it. Okay, so basically we have this acute angle triangle. I don't really know what the acute angle means. I don't think I used the acute angle condition in this problem, so yeah. Anyways, we have an acute angle triangle in the circle, and we're trying to find the ratio of the magnitude of OBE, which is this little angle right here, OBE, to BAC, which is this angle. And we're given arc AB 120, arc BC 72, and the point E on the minor arc AC. So we know AC, it's given that AC is a minor arc because AB plus BC is obviously greater than 180. So the ratio of OBE and BAC, let's take a look. First of all, let's mark the angles that we're trying to find with some color. OBE, that is the first angle. The second one, I'm going to use blue, BAC. You know what? I'm just using blue for both. So it's not easy to actually get OBE onto BAC and just find the ratio from there. So an easier method is probably just to actually find what each of the measurements are and then take the ratio. So I'm gonna pull this over here so I can still look at the measurements. AB is 120 degrees. Mark it with a different color. Don't know if you can see it well enough, but this is 120 degrees. And then BC, 72 degree arc. So we know that ABC, no, sorry. No, it's right. Yep, 72 degree arc. And we know since BAC, the angle BAC is just going to be twice of arc BOC because, no, half of BOC. What am I saying? Half of BOC, 36 degrees. And now we just got to find OBE. Notice that OBE is obviously isosceles, and this is just another trick that I feel like is really useful in all circle geometry problems because you're going to have a bunch of triangles that are made of radius and they're going to be isosceles. So that's really important. So we know that OBE is going to be equal to OEB. So now we just got to find this top angle right here. We already know the 72 and we just got to find the EOC. And now comes another isosceles triangle. Notice that AOC is another isosceles triangle. And since EO is perpendicular to AC, which is given in the problem, by the way, I forgot to state that, we know that angle AOE is going to be half of angle EOC right here. So we're just going to find all of AOC and then take half of that. So what's all of AOC? 360 minus 120 minus 72, which gives us, what does it give us? 240 minus 72, 168, I believe. So half of it will be 84. So 84 plus 72, that gives us the top angle of this triangle, which is 84 plus 72, 156. So the two bottom angles added up is going to be 24. So one of them will be 12, I believe. Wait, am I right? Yep, one of them will be 12. Wow, I did all that mental math really well. So the ratio is going to be 12 over 36, as we've already found earlier. So the ratio is 12 over 36, 1/3, which corresponds to the answer choice D. Okay, so that is the AHSME problem 22. I would say the more difficult one of the two that we're doing today. Now this is the other. Don't look at the answers. Okay. The length of the sides of a triangle are integers, and its area is also an integer. One side is 21, and the perimeter is 48. We're trying to find the shortest side. So since right now we're given they're all integers, we're probably going to be doing a little bit more algebra than actual geometry, which I would say, yeah, this problem probably belongs more in the algebra section than geometry. But it doesn't matter. The area is an integer. Now we're asking about the area when we know the side length. So automatically, you should think of the Heron's formula. I mean, I didn't automatically, but I looked at solutions, but that's also because I don't make math. Anyways, that's this scratch paper from last time. So we know that one side is 21 and the perimeter is 48. So the semi-perimeter. So first of all, let's restate the Heron's formula. square root of p times p minus a times p minus b, p minus c. So in this case, p is semi-perimeter 24. So this is going to be SQRT of 24 times 24 minus 21. That's 3 times 24 minus, so since the perimeter is 48, one side is 21, the other two sides are going to add up to 27. So 24 minus x, and then 24 minus 27 minus x. Hold up, what am I doing? 27 minus x, so minus 27 plus x. Yes. After we open the parentheses of 27 minus x. So now we just have to find what value of x makes this an integer. Obviously, I tried like forever to solve this equation and I failed, and then the solution told me all I had to do was plug in the answer choices. So like, bro. Anyways, notice that those 24 is going to be 4 times 6, and then we have a 3 right here. That means the squares of 3 are complete. We don't need any more 3 in these two terms for it to be an integer, square rootable. And we also, however, we do have one extra 2. So we just need an odd number of 2 and an even number of 3 over here, and an even number of whatever other term it has. So also we should just probably simplify this to x minus 3. Yep. So now we plug in the answer choices. The answer choices we're given are 8, 10, 12, 14, and 16. Which one of those makes the equation complete? Which it will just be 10. Obviously, we plug it in and find out it's 10. So yeah, we choose answer B. Okay, that is it for the video today. Just a quick recap. I feel like I actually did pretty like a bunch of math over the trip. If you will take a look, yeah, a bunch of algebra. I don't know why I did so much algebra, and also I should probably like start doing a little bit more difficult problems, because even if I can do any intermediate algebra, geometry, combinatorics, number theory problems, AMC is going to be like quite a bit harder than that. So right now I'm just really practicing my speed and accuracy with this, but actually ability to solve harder problems like 20 and beyond, I might need a little bit more difficult than just intermediate aops problems. And also my videos, no one's going to watch my videos when they're all just intermediate problems. Okay. But you are, whoever you're watching this right now. Anyways, see you tomorrow.